Okay, now we're going to talk about where do the electrons live inside of an atom. And in order to understand this, we need to use the laws of quantum mechanics. So quantum mechanics is a particular way of describing how things work at a microscopic level. Things that are the size of atoms obey the rules of quantum mechanics. Now, in order to understand quantum mechanics, you're going to need some mathematics. So this is an algebra-based physics class, and so the next thing after this would be to take calculus in college, and then you would be able to take calculus level physics. And so any physics person that is going into physics or engineering or becoming a doctor is going to need to take calculus-based physics, which is a 2-semester course. And then after they do that, then the very next class that they take is called modern physics. And in modern physics, they would learn the rules of quantum mechanics. Now, since we don't have time to learn calculus and all this high-powered mathematics, I'm just going to tell you the results of quantum mechanics. So as I give you these numbers, you're going to be saying why. And all I can say is because, okay? Because of quantum mechanics. So if you're interested in this, you can look some of this stuff up on the internet and do more research on this. But let's just cut to the chase and talk about where do the electrons live. So in order to understand this, I want you to think about a hotel. And a hotel has rooms where people stay. So according to quantum mechanics, there is a thing called the atomic hotel where the electrons live. And the electrons are going to try to go as low as possible in this atomic hotel. And just like a real hotel, this hotel is going to have floors. Now these floors are going to be called energy levels or energy shells. And so that you're going to have N equals 1, so that's going to be the ground floor of the apartment building. And then you're going to have N equals 2, and then N equals 3, and N equals 4. The N is called a quantum number, comes out of quantum mechanics. Don't worry about it. Just know that this thing has floors, and the higher up you go, the more energy you have. So it's like if you take this pen and I drop it, did you hear the noise it made? Okay, if I drop it from up here, did you notice it made more noise? So the higher up I go, the more energy you're going to have. So the electrons that are up here have more energy than the electrons that are down here. Now, according to quantum mechanics, the first floor can hold 2 electrons. That's it. So on the first floor, only 2 electrons can live. Now, when you go to the second floor, there are 2 rooms. Okay, so let me subdivide the second floor into 2 rooms. And now one of the rooms is identical to this room down here. So this room can hold 2 electrons, and then this room over here can hold 6. Okay, so instead of, I'll just put the number 6 in here. So it can hold 6 electrons over here. Then when you go to the third floor, which we don't care about, okay? So this isn't chemistry, don't worry about it. But if you go to the third floor, do you want to make a guess? How many rooms would you have? Well, it's in the picture there. So you'd have 3 rooms on the third floor, and then if you went to the fourth floor, you'd have 4 rooms. Okay, but we're only concerned about the rooms that can hold 2 and the rooms that can hold 6. And so the rooms are going to be called subshells. The floors are the shells, and then they're subdivided into subshells. Another name for this is an orbital. So you have orbitals inside of these rooms. So the ones that can hold 2, you need to know, is going to be an S subshell. So S's can hold 2 electrons, and then the ones that can hold 6 are going to be called P's. That's all that you need to know for the exam. Okay, so that if you notice though that I listed the ones that this one over here can hold 10. So do you notice it goes 2, 6, 10? So it goes up by 4 each time. And then the ones that can hold 10, those are called D's. And then the ones that can hold 14s are called F's. Don't worry about it, okay? So let's just concern ourselves only about the S's and the P's, because we'll be able to explain quite a bit just by using those two. Now, in your textbook, and also if you read basically any textbook, they also have a different way of visualizing the atom, and that's with rings. So if you look at that particular element, magnesium, you notice it's got rings around it. So each ring is a floor. So you got the first ring, the second ring, and then the third ring. And then you'll notice that it's holding the same number of electrons. So on the first ring, there's 2 of them. And then on the second ring, you notice that there's 6 plus 2 makes 8. Okay, so that's how they, is another way of visualizing what an atom looks like. But remember, it's not correct, because the electrons do not have nice orbits around the nucleus. Instead, what it really looks like is different areas or different volumes that contain electrons. So don't worry about this. I'm just giving this to you for entertainment value. But if you look off to the side on that chart there, you see that red sphere up at the top. So that red sphere is a depiction of what the S subshell actually looks like. It's a bowl. And then inside that bowl is where the 2 electrons live. And then underneath that is a depiction of the p orbitals, which hold, there's 3 p orbitals that hold the 6 electrons. So 2 plus 2 plus 2 makes 6. And so those are those yellow things. And they look like dumbbells. So if you take chemistry, you will learn all about those pictures. But for now, don't worry about it. Let that information just ooze out of your head. Doesn't that feel good, letting it go? All right, so let's keep going here. So the important thing is now you know about the rooms and you know about the energy levels inside the atom. This really is very important, because we'll be able to explain a lot of physics and chemistry just by going back to this picture here. Okay, let's take a break. When we come back, we're now going to fill in the atomic hotel.